Hello, hello. How's it going, chat? Welcome to Demo Days. Namaste. Hello to our friends from Azerbaijan. Hello, hello. Git commit. Hi, everyone. Nice. I like. Good to see you all. Welcome. Good morning, good evening, good afternoon, good night. Always nice to see everyone from all over the world tuning into Demo Days. I'm guessing a good number of you are coming back from other Demo Day sessions, but if this is your first time today, welcome. Today is actually going to be the second conversation that we're going to have around the topic of infrastructure as code. And last time I asked in the chat if, excuse me, if the topic was brand new, and it was for many of you. So we talked about infrastructure as code from scratch. This week, however, we're going to take a different tack by looking at how GitHub uses infrastructure as code to deploy. And hopefully you can learn a bit from our example. So if you find this demo day useful and want to talk about how it might apply to your company's specific context, feel free to use the QR code that I just popped up onto the screen, and you can book a meeting with us. In any case, today, to help me with the topic, I would like to welcome Jürgen. Jürgen Efeish, Senior DevOps Engineer here with GitHub. Welcome, Jürgen. Please unmute. All right, cool. And take it away. Nice to have you.
All right, thanks for that nice introduction. So guys, yeah, today we're here to talk about the second part of the infrastructure as code. I'm gonna start out with a little bit, before we get to the demo, a little bit with some overviews, some topics that I like to address, some parts of infrastructure as code that are important to me based on, yeah, my past experience in kind of enterprises where it's actually applied. So let's take it away. Let's go in there. Here we go. Okay. Yeah, first thing is when it comes to infrastructure as code, many times when I have a conversation about this, I try to make the point about provisioning versus configuring. Like what you provision is your infrastructure. Configuration is in many cases part of the infrastructure, but we build infrastructure to host applications and services. And these applications and services, they have their own configuration. Why do I bring all that up? It's because when you start building your infrastructure for a specific application or service, you start out with just a basic infrastructure that then you drift, I would almost say, into more and more the application configuration code. And even so that is sometimes necessary, try to separate these things. Try to kind of, yeah, decouple these two items. Because you can deploy many times the same infrastructure for maybe multiple different applications. But if you bundle these things together into the same infrastructure as code, then you create dependencies that in the long run, yeah, they might hurt you or might make it harder for you to reuse that infrastructure as code or even to grow it. So keep that in mind. But one last thing, many tools, they have this where they say, you know, I'm made for provisioning, but if you want to configure things, you can do that too. And the same way or the other way around. I'm made for configuration, but if you want to provision something, you can do that too. There are no clear boundaries with these tools. They tend to overlap. And it's up to you to make that call. Going into the targets. Yeah, everybody talks about infrastructure as code and yes, how we do it. But a couple of items, goals you need to keep in mind what it has to do for you from my perspective, right? It creates an immutable infrastructure. It's the old term, cats versus cattle, right? So back in the days when you built something, it took you a long time to build it. So now you're very, very attached to it, almost emotionally, because if it gets destroyed, it will take a long time to rebuild this. But infrastructure as code will change that, or has to change that. Nowadays, yes, you spend some time building it as a code part or as a plan, but from that point on, it has to be able to be thrown away, right? In a heartbeat. If something breaks, if something is not right, you just run your infrastructure as code again, you rebuild it. That's why you don't get attached to what you build, because it can be recreated at any time. Idempotent infrastructure. That is an interesting thing for me, specifically when you talk about the cloud. Definition is, if you run the same thing twice, you should get the same result. To give an example, and I had that versus Terraform versus Ansible. I'm just throwing these tools out as an example here. If I tell Terraform to create 5 nodes for me, EC2 nodes or compute nodes, whatever you want to call them, in the cloud, Terraform will create these 5. If I run this Terraform plan again, Terraform will know how many nodes are out there. It will not create more than 5. If one node got destroyed, it will add 1 to have the total number of 5 again. Ansible, on the other hand, if I tell it to create 5 nodes, it will create 5 nodes again and again and again and again. Again, I'm not trying to throw any of these tools under the bus, because even Ansible, clever programmers, program around that. They make playbooks that are smart. But by plain definition, this is what you have to be careful about, especially what I'm showing you later when it comes to self-service. You're handing your infrastructure as code over to the world, or at least your internal enterprise. That means anybody can push that button and create the infrastructure that you have designed, and they can recreate it in the cloud as many times as they want, which can lead to, extreme costs. So all that gives you in the end the managed infrastructure. That's of course, that's why we're here. That's why we want this. We have a consistent system now. We can rely on it. We can hopefully trust it because it has been approved before it gets pushed out. All these things are now standardized. One last thing is that phrase, I can tell you that, is I got that from a developer when I worked in one corporation once, who told me, Jürgen, what we do is change forensics, we don't do change control. And that was the lack of infrastructure as code. It was a funny statement in one way and it's scary in another way. It is true. When you have infrastructure as code, you have change control. You now have a control system that you deploy. You know what went out there into the cloud. And if you don't have that and things break, you end up with change forensics. You try to figure out 3 o'clock in the morning, oh my God, what went wrong? What did change and who made that change to the infrastructure live, basically. Think about your production system. That's the scary thought. Putting it in perspective with infrastructure as code in DevOps. When I have to deal with infrastructure as code, I'm sometimes in 2 different positions. Sometimes I'm the receiving end, the ops end, right, where the automation, the self-service lets me benefit from infrastructure as code. And especially that's what we do in GitHub with our demo later. And then there's sometimes the part where I'm asked to create that infrastructure, right? Provide that initial optimized, tuned infrastructure platform for our service. So when it comes to that, GitHub as our platform provides us with the branch protection so that nobody just pushes in code that is not approved. Right? We do this with branch protection, like I just said, pull requests, and our repositories have code owners, and we turn the branch protection on to request the code owners to approve things. So from that perspective, we have a change control process in place. That really allows us to do one thing that I like. In some cases, it's, how can I say that? You work in a department, you're responsible for a certain domain, and the department has a limited size, right? Let's say it has 10 people, and these 10 people maintain that code. So if there's a lot of demand for change, it will always be these 10 people to change that code. But if you use the branch protection to pull requests, this whole kind of inner source process, you can have anybody from within the company look at the code and say, you know what, I found a bug, or I found a better way to do this. Open a branch, submit a pull request. And the team that maintains this is actually the only role they play at this point is the approval. So you extended your workforce virtually. So I like that part when it comes to our inner sourcing. Let me go to the next. Yeah, here comes a little bit the experience part, or even more of the experience part. What makes infrastructure as code work? The moment you put your code in source code control, for us, of course, GitHub, it has to be the source of truth. And what I mean by that, I have defined it here. If a resource is not declared in GitHub infrastructure as code, it should not exist. So back in the days, you might have coded your infrastructure like via scripts, then went onto the machine and made manual modification, tuned. Right? These things you have to suppress. I mean, it happens, I know, sometimes when you figure out, oh my God, we have to do a real quick hot fix here, we have to log onto the machine, we have to change these things, fine. But they have to immediately go back into your infrastructure as code because it has to be in sync. Think about what I said before, immutable. If it's not in sync and your infrastructure gets destroyed and you run it again, what do you end up with? You're now ending up with what was on GitHub, but that was not the same system that you just had being destroyed on the cloud. So make sure GitHub becomes your source of truth. I'm jumping on the same thing again, like I said before, the inner sourcing, the collaboration, right? We enable global collaboration. That's the little story that I just gave you with some users now being able to, or anybody in the company being able to participate, I would say, cross departments into other people's code, which is very useful and helpful. And what it helps us to do is, and I said it here, right, reduce the importance of location and time zones. It, in many cases, I live in New York, so if I maintain things and it's in my time zone and somebody wants an approval from me, does he have to wait? No, he doesn't have to wait, right? We can globalize the whole code segment here. Next thing is trust your infrastructure as code. That is something you have to very much keep in mind. It's not you write it once, apply it once, and then forget about it for the next 2 years. I've seen that happening, and I've seen people looking at machines and saying, hey, wow, the uptime is 3 years. And there were two reactions. First reaction was like, oh my God, 2 years, this thing is really stable, awesome. And the second reaction, like, oh my God, 3 years, that's scary. Because what happens if we shut these things down? Can we really recreate it? I said it before, your GitHub has to be the source of truth. That is still my statement, but you still have to exercise that what you just committed to your infrastructure as code is still working and valid. So for that reason, many companies actually do this cattle versus cats scenario and tear their infrastructure down, even production. They tear it down frequently, sometimes quarterly. We have companies that do it monthly. And that's kind of a scary thought that you're actually tearing down your production system on a monthly basis. But when you do it right with infrastructure as code, it becomes much, much less scary. And I prefer that you do it often, because if you see something, you can do something. Right? If there is a bug and you have your unit tests and your QA testing going on, you can at least fix it in time. If you do it in a managed way, that is fine. Everybody knows it's happening at the end of the month. But the critical part is you need your infrastructure as code the moment things go wrong. Like I said, 3 o'clock in the morning, your system crashes. Now you need infrastructure as code to recover, and it needs to work. Nobody wants to trouble infrastructure as code at this time. The last thing I said, follow the GitHub workflow. Again, half a dozen times I mentioned it now. For me, the infrastructure as code workflow is literally the GitHub workflow, right? And with the previous stuff where I said that you exercise your infrastructure rebuilds frequently, you definitely prevent the drifts that can occur. They shouldn't occur, but God forbid they do. you can prevent these things. You can have, in Terraform's case, run it against your plan and check that Terraform tells you, hey, you know what, there's 5 resources out of sync. If you would literally run me right now, I would correct these resources. But this is, I think, the basic picture here of what makes infrastructure as code work. Now, when it comes to the infrastructure as code in GitHub, there are a couple of parts of IAC. I'm using a shorter version now. It makes it easier for me. So IAC, under the covers, you have definitely in the middle, that's the definition, your declaration, right? In Terraform, it's a plan. In Ansible, it's a playbook. You have your parameters. When the parameters go into your declaration, they together, in the combination, they define what you're building out on, let's say, the cloud. And that results in a state. The declaration, we store it, of course, in our own repository. There's no big deal. Everybody can reuse that repository, refer to it. If you use it with your own parameters, then you can make it specific. The same declaration with different parameters can either be used for standing up production infrastructure or QA or whatever any infrastructure you want, development infrastructure. What's important is maintaining that state and managing that state. I go back to Terraform. Terraform creates state files. These state files are very important because they are the memory for your Terraform tool. Right? Next time you run it, Terraform looks at that state file. You have to reference, of course, that state file, and it says, okay, based on the state file, this is the stuff I stood up last time, and now you want me to run it again. Now let's compare what actually needs to be updated. With that state file, you get this idempotency, right? It will look at the same stuff it did before, and it will address the same resources. It will not create new ones. Without a state file, it will always just create a new one. State file, important thing is, for Terraform, it has sensitive data in there. So for dummy purposes or development, you can literally put that state file in an extra repository, make it private, right? Make sure that nobody can see it, and only your CI/CD process can refer to it, which, yeah, it's a poor man's protection plan, I would say. In reality, you can do remote state, you can use S3 buckets, whatever you like. You have to look at what Terraform specifically provides there. And now one closer look at the demo stack. Yeah, in the beginning we talked about, right, how does GitHub do its stuff? We have in-house something that we call the demo stack. And GitHub Professional Services uses infrastructure as code for standing up a demo stack. What does it really mean, the demo stack? For us, it's standing up our GitHub Enterprise server in multiple configurations. You could have it as a standalone one. You could have it as an HA setup with multiple instances. We have backup utility machines that we can deploy. And in addition to our own product, we also have plans out there that allow you to stand up CI/CD tools in combination with our GitHub Enterprise server, which, as an example, simple one, Jenkins, right? And we stand up LDAP servers. So from a services team, if you need to test something, you need to simulate the customer's environment, we just go into our infrastructure as code, use that, and pick the specific plan or infrastructure plan that we want to use. And within roughly like 15 minutes, depending on how busy the cloud is, we have a full infrastructure that we can log into, that we can play around with, and yeah, exercise the way we like it. We don't have to ask anybody for approval. We don't have to wait for other people to, we don't have to submit a ticket and say, oh, can you do this for me? This is all self-service. So, like I said, 15 minutes, we're pretty much in business with any kind of infrastructure that we need internally to do our work. At the bottom here, you see the demo location. That little link has a repository. In that repository, I'm combining two things. I'm combining something that is called Hubot and our infrastructure as code plans. They're in the same repository. So when you clone that and follow the README instructions, you should be able to replicate everything that I'm going to show you in a bit. What our demo days now use as a demo stack, literally, is I told you about our internal demo stack and how big this thing is. It is really large. Over time, it has grown, and it does some really impressive things. But for our scenario here, I just cut out a little piece and said, okay, let's build an enterprise, GitHub Enterprise server on the cloud. We're doing one in Azure, and we're doing one in AWS. How do we do this? This is pretty much the big picture that I was mentioning before. You see the components there. We have the Chatops, we have self-service automation, and at the end, we get our managed infrastructure. For Chatops, we are using Slack, and we're using Slack bots. Our implementation, it's open source for the Slack bot, or not Slack bot, for a bot in general. And that bot has an adapter for Slack, is Hubot. You will see it when you look at the repository. There's a link to Hubot. We walk through this in a short while. So Hubot is our little helper. And a while back, there was an article where somebody, I think, if I can remember it correctly, it was saying the busiest person in GitHub is not a human being. And that's actually true. Hubot is doing extremely, how can I say it? It's a lot of things that it does, not just infrastructure as code. But for today, we focus on that. Hubot triggers the infrastructure as code, right? It triggers the Terraform, and then that Terraform goes out there and builds our stuff in the cloud. These four components we're going to walk through. And here comes the magic moment, the demo. Let's see how I can switch to the other screen. Give me a second. Alrighty then. Okay. So I mentioned before that there is this repository that you guys can all clone. It is public, but it has branch protection, so at least I have control over it. And I just jumped right into the README file. For a moment, just ignore my little console windows here. I'm going to go into that in a second. But I want to go over this little README. So we have our demo days, yada, yada, yada. The overview, it's the same stuff that I just mentioned to you, these four components that we're going to build. Right? The infrastructure as code, our declaration. Okay, we're standing up a basic minimum one. It's the same what I just had on the presentation. And here comes the most important part. Now we're starting to get active. In order to run this demo, you need a couple of components. I said it before, I'm using for our demo here Terraform. So just to verify that I have everything I need, let's go there. There we go. I'm having version 15. It complains because they just released version 1. That's a big milestone, but we can live without that. So looking at NPM, okay, typing is difficult. Here we go. We got this. We got, here we go, version 16. You see a little bit what I have. We have AZ. I have like already logged into that. So that's Amazon, Azure's client. And of course I have also AWS's client. Okay. All right. So with all that, it seems like at least for my tools, I have everything ready and installed. I can go ahead. I did clone it like you see it here. Let me highlight this for a second into my little folder called Projects, Demo Days, GitHub. I refer to in the README that, yeah, for simplicity, that you put it into your home directory, because all the references you see in that README are regarding to that home directory. But with that, what we need is two more items: Hubot itself, and we need Chatops. Hubot, I'm gonna open this in a new window for a second. I know it's all about infrastructure as code, but in order to make it work perfectly in a self-service environment, we use this little guy. It's open source, like I said before, so you guys can look the code. You can even make modifications the way you want. So it's very, very flexible. There is no secrets hidden anywhere. But with Hubot, there's also Slack adapter. Hubot has many adapters. Hubot can connect to Slack. That's what I'm using right now. It has a local connectivity. We have used Hubot with SSH connectivity. So if people want to use this internally and do not want to expose it to any kind of outside world, they use SSH. But right now, this is the Hubot adapter we're having. There we go. Again, all available, open source. If you want to install it, that is relatively easy. I give you a link here, and here it is, install a Slack bot. If you click on that guy, open that, you will notice one thing. It takes you directly to a page from Slack that allows you, to add this bot to your Slack account. Of course, you have to have one. And if you are logged in like I am, if you see this up here on the top right, then it will allow you to right away click add it to Slack, and it will add this Hubot app to your Slack account. What it will end up doing is, you see it down here in the apps section, you will have a little Hubot. This is direct connectivity to Hubot. This is not Hubot being in a channel, right? This is you talking directly to Hubot. But with that, you are basically in business. Let me get out of this and see what else we have to do. Oh yeah. Most important thing, the way it works is, the moment you install a bot, you create an API token. Right? Slack creates an API token for you. You can regenerate that token anytime you like, but that API token needs to be passed on to Hubot. Hubot needs to know that. Hubot, with the Slack adapter and the token in combination, is now able to talk to your Slack account. And with that, we are able to start executing some smart code, hopefully. I'll show you what it is. I have, in a second, I have Hubot running here. Let me explain this 1 second better. I realized I'm missing something for all of you, unless you have downloaded or looked at the repo. Almost missed a step. Like I said before, I have bundled everything into one repository for demo purposes. In reality, that wouldn't be the case, but here we have. I have an IAC section. Here's my Terraform. Here's my different plans for different clouds. Underneath, you will see a little bit more. We go in there in a bit. And also in that same repository, there is my fully installed Hubot. So normally you would have to go out there and install your Hubot, create a little project, run Hubot, configure it. I've done all that stuff for you. And that's what I just did. I went into that Hubot folder, and underneath there's a Hubot executable. And I'm running that Hubot executable. If if you can see this, I have to make it a little bit wider. I'm running Hubot, and I'm telling Hubot the adapter it has to use is a Slack adapter. So kick that off. On the right side, I'm tailing the logs. You just saw how it moved. So with that, I can actually talk to Hubot and say, help. As you can see, Hubot just reacted. If I kill that guy just to make sure, regression testing, if it's really that guy we're talking to, nobody's on the other end, nobody's gonna answer. So bring them back into business, start them up. We're good to go. We have Slack running. Let's go back to our demo days setup. Here we go. First thing we cloned. Yes, we cloned the repository. Like I said, simplicity reasons we put it in a home directory. Next thing we do, and I've done that on my end before, just to make sure that everything works and to beat Murphy's Law. So I talked about that as soon as you install a bot into Slack, you get a token from Slack. You take that token, you provide it to Hubot by means of like environment variables. I also started to tell Hubot, hey, here's your log file. Please log into that log file and set the log level to debug. All these things I have set up, right? You saw me doing this specific step here where I said, okay, Hubot-A, run it with a Slack adapter, and we are in business. I didn't do the ping and pong. I just used the help, and the help came back. So Hubot is active and running. So from that perspective, we are connected. So step 2, prepare the infrastructure as code. When you run this demo on your own, make sure that there is a clean start, I would say. If you don't have anything that was deployed in the cloud, make sure that this state file, a state folder, is empty. I mentioned to you before, you have to maintain your state somewhere. You can do it remotely, you can do it locally. For demo purposes or development, mostly people run it and let it sit there local on their machine. Not a big deal. If you talk production and security, you have to put it somewhere else in a safe place. Right now, we are putting it in this specific folder where we say Terraform, GHAs, AWS. So one state file, a state folder specific for AWS and one state folder specific for Azure. Under this state folder, you will see that we're executing things per user. I will explain in a moment what that really means. Credentials, I use the basic stuff. I have logged into Azure login, so I'm authenticated with Azure. Azure lets me go in and execute my Terraform plan. Similar thing with AWS. I have my credentials on my system, so I can test away. Now let's run, like I said before. Step 3, we're already tailing the logs here on the right side. And we are now able to go actually into Hubot. And you saw that I had, I don't know why this is telling me today. Let me see this. Help again. Don't worry. Here we go. So the one command that is specific that I added to demo this is Hubot demo stack build or destroy in GHE infrastructure. I'm not explicitly saying what infrastructure it is because I have only one, so I say demo stack build or destroy. If you want to be specific about what versions you want to build and destroy and in what cloud, you can deploy these extra parameters. By default, I'm doing GHG Enterprise, GitHub Enterprise 3.1 on Azure, right? But let's exercise one of these. I do agree there's a little bit of a cheat here because I built it before. I did not want to sit here and wait 10 minutes. which is what would happen. And the bot would just sit there and we would watch the bot do nothing. So let's say we take this 3.1.0 and we say Azure. All right. Oh, sorry. You saw me doing something. I didn't type demo stack. I typed DS. We have a regular expression out there where Hubot understands demo stack, DS, demo stack as one word. So all these three options are out there. We're making it a little bit shorter. As you can see right now on the logs, it has received the information, has received the request. Anything that is Terraform specific that Terraform wants to tell us, I'll make it a little bit bigger here. You see, we're running in an init state for Terraform. And after that, we're automatically going into the apply section for it. So give that a couple of seconds. Here we go. So here comes the immutable part. It refers to the previous state file that was created on the first run. And with that, it knows that it doesn't have to create a new one. It goes out to the system, checks what needs to be updated or not, and it returns our information about the current stack. Show you what it is. Actually, I might have had a change in the code that could have happened. Seems like it, so it's destroying something. Fortunately, that will take a little bit longer. What happens is Hubot, here's the details. Hubot receives the call, Hubot fires off a little wrapper script that handles all the Terraform interaction, and Hubot has a stream connection into that little script. So Hubot now can still interact on other commands, right? We can type whatever we want. We can type another help or trigger another infrastructure as code setup. But by the time our setup finishes, it returns to Hubot, and I gave it here a little demo on the picture here. It returns to Hubot, and Hubot will tell you, hey, this is your infrastructure. Here's your IP address to connect to it, and you can just log into the system. That is unfortunate that it had to make these changes. I thought I didn't have that, because now we can talk about, you see 40 seconds. In reality, this will probably take 5 to 10 minutes. It destroys a whole resource group, and it will create that resource group. So this is Murphy's Law. I didn't expect that specific thing to happen. Let's assume everything is ready to go. I do have already an infrastructure that I built for, where is it? Let me see. Go there. For AWS. Let's make a new one. Bring that in. And let's log in. I'm deploying my stuff to US West 1. The flexibility of the plan is not extreme at this point. It allows for the different appliance version, but we did not go that far, to, here we go. There is a running instance I created before. Let's have a look at that instance. It has a public IP. Sorry, I did not create a certificate, so now it's complaining. But here we go. That's what you will end up with, because I did not have a license. This is bring your own license. as a demo. So if you have a license, you plug that in here, just provide an admin password, and after that you're in business. Right? This is the setup that you need to complete. The key element for me is our product team or the developers of the product. They can create, spin up another release anytime they want. As soon as they feel like this release is ready for GA, they create an appliance, and that appliance ends up in the cloud in a marketplace. And from that moment on, anybody in our services team can connect to it and play with it, download it, do whatever they want. So it's a very, how can I say, decoupled operation from both ends, right? Everybody can work without having the other one being a bottleneck. And we're doing it like I just tried to show you. Hopefully it's still doing its job. We're doing it on both cloud environments. And that is, let me see what the next thing is on my list. Yeah, I gave a couple of images so that you would not sit here and wonder what it should look like. Yeah, I wanted to bring up one thing is looking at, like inside the box, the state. I am down here in my GitHub folder. Let's go for infrastructure as code. We can go for Terraform, GHES, and I do want to look at AWS. And there it is. There is a state folder. Bring that up to show you what that looks like and why I'm bringing this up. You will see it in a second. We are organizing state files based on users. In Slack, you're a user, you're a registered user. When you communicate to Hubot, Hubot knows what user you are. So it extracts that user ID and creates that state or memory in the specific location. With that, we can have multiple people, multiple users use the same Slack, request an infrastructure as code, and they get their own little instance maintained only for them. Why is that so important? It's important because you saw it before, we have a build and we have a destroy. We want to tear down our environment when we are done. In our real demo stack, we use something like a lifespan tag that we attach to every stack that we're putting out there. That lifespan tag is 8 hours. After 8 hours, we automatically tear down your infrastructure. Again, cats versus cattle, right? You can always recreate it, but it doesn't have to sit around for more than 8 hours. If you do need more than 8 hours, you can provide it as a parameter and can tell you know what, I need it for 12, I need it for 16. We have a maximum of 48 hours, but we say, okay, 48 hours is enough. That stuff can really, really cost money, specifically when you talk about hundreds or thousands of people that use that self-service. So that is why we have these grouped per user. You can then tear down something for yourself, and only you can tear your own stuff down. Nobody can go in there and say, hey, I want to tear down stuff for Jürgen. It's not going to happen, right? You own it, you're safe. What we also, last kind of statement here is, I brought it up before, the immutable and idempotent. We now have that with that kind of statement management. Like I said, we can destroy it, we can rebuild it anytime we want. We force an 8-hour destroy on you, which is just for, I would say, resource consumption reasons, right? And we can have multiple instances running for multiple people. But when you run your stack again, like you saw, actually, it's a good example. What had happened on Azure, I ran the same command again, but I'm not sure if the previous version was different. Maybe it wasn't 3.1.0, maybe it was 3.0.1. And with that in mind, it has to tear everything down, but it doesn't create a secondary stack. It just updates the stack that is owned by you. Whoa, that was a lot of talking on my end. I guess that's pretty much sums it up in terms of what we do in GitHub as infrastructure as code. I have to say, the longer you use this, the less you become aware of actually what you do. Meaning it becomes a very convenient tool, and after a while, we don't even ask ourselves anymore what's going on behind the scenes. Like you see, it takes like 10, 15 minutes to build this, and all these components are involved. But the user, yeah, since we're using it with Slack, you can operate it from anywhere. You can literally operate it from your phone. And by the time, yeah, you're commuting, hopefully soon again, and you will be able to say, okay, stand up a full-blown stack with multiple systems, whatever it is, LDAP, et cetera, et cetera. And by the time you hit the office, the stack will be ready for at least 8 hours. Oops, and I saw something popping up on my screen. I hope everybody else saw the same. Hubot just told me it's done. And that means I can stop talking. See what happened? Hubot told me, hey, here's a response from your Terraform run. Right? I have a couple of output information here, pieces here. You see, I have an output of a private key that I generated for our resources here. And as you can see there, it says sensitive, which is good. When you refer to Terraform and tell Terraform, please output certain information, Terraform knows what is sensitive information, and it will redact it. But it is still in plain text in your state file. Right? This is not a binary version or anything encoded. It is there in plain text. So therefore, like I said before, security reason-wise, please protect your state file. Make sure it's in a safe space. Same thing goes for Slack. Hubot is, you can look at it as another user in your Slack channel, right? And instead of talking to Bob, now you're addressing Hubot and you say, Hubot, please do something for me. And Hubot, with the Slack adapter and our Hubot code, might have access to resources, GitHub as an example, right? Or any other third-party tool. So you have to keep that in mind. When you tell Hubot to do something and Hubot has the permission, Hubot will go out there and do it. So you have to limit that access. You have to make sure that Hubot is on the right channels. We do that. We have checks and balances in our Hubot that actually says, you know, you want to see a private key, you can't do it. Or not in this channel, you have to go somewhere else. So we have these things, but keep that in mind. Security, I have pushed aside for a moment. All right, now I really stop. And if anybody has any questions, please, yeah, feel free, let me know.
All right, great. Thank you, Jürgen. That was a tremendous session. I see some folks in chat asking for a further session in terms of security and how it all relates to IC. So hopefully we can come up with a program in the near future to talk about some of those things.
It's, in terms of security, I mentioned before, but just to remind people, that's why I kept saying this is open source. Right? There is nothing hidden. If you have security teams in your company there and you want to use Hubot, you want to use these Slack adapters, it is in many ways, yes, it's hard to convince people, hey, I want to use this. Can you approve this? But if it's open source, that makes the whole process a little easier because people can look inside. And you can even enhance these adapters with additional security measures.
Yep, amazing. And also, you know, if you do want to take this topic further, we are going to take a break next week, but we'll be back the week after with the closeout of this topic of infrastructure as code. Also, as I mentioned before earlier, if you want to talk very specifically about your situation and context, go ahead and hit up the QR code. Until then, thank you once again, Jürgen. And thanks to everyone on LinkedIn for joining us for another wonderful Demo Days. I hope you have an amazing weekend and stay out of heat and stay safe, please.
All right. Thank you.
Bye.